So let's now begin with the second phase of this Pandas library. In our first phase, we have covered four things: introduction, the series, data frames, and the missing data. In this one, we will talk about the group by, merging, which is basically joining, and then concatenation, and the operations that we will be working on. Okay, so with this, let's begin. So the first topic is about the group by. If you guys are aware about SQL, it is similar to that. And if you are not aware about SQL but are aware about Excel, then it is similar to sum if, average if, all these conditions. If you are not aware about Excel, so let me show you the code and then it will be much more helpful for you to understand. First of all, like I will import pandas as PD and import numpy as np. Okay. Now I will create one dictionary. Let's call it my data. I'm creating a dictionary. Let's say product is the key and their corresponding values are VA, which is variable annuity, variable, four times variable. And let's say fixed index annuity, four times fixed index. Uh, One, two, three, four. And let's create endowment. Let's call it endow. One, two, three, four. And let's create one more, that is term insurance. Let's call it term. One, two, three, four. So that is the first key product, and these are their corresponding values, comma. The next key will be, let's say, state zone. So we have created this 16 values, right? 4 VA, 4 FIA, endow, and endowment, term insurance. So state zone is the next key, and their corresponding values will be, let's say, A, B, C, D. So let's make it again four times more. Four times, four times, four times. Make sense? Last one, not last one. Let's say I have received the total premium of, let's call it 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1350, 1450, 501650, right? And the last variable, let's last key, let's call it number of policies. Number of policies is the key I am creating. The values will be, let's say, 10, 20, 30, 40, 50, uh, 60, 70, 80, 12, 22, 32, 42, 52, 62, 72, 82. Okay, 16 values. Let's trigger this. Now if I take a look at my data using the data frame, so let's create a data frame, pd dot data frame, and this is my data is my data is my data. Okay, so now if I trigger this, now if I take a look at my data frame, that's how it looks like. By default it has given me the index, and these are their corresponding column names. Okay. So yeah, so we have created this data frame. That's how it looks like. Okay, pretty simple. So now what I'm saying is that on the basis of product, I want to find the total number of premium I have received and the total number of policies that I have sold on the basis of product. Okay, that is what I'm saying. So how to do that? I will type df dot group by, df dot group by. Okay, and within that I will type the name of the column, that is product. Now if I trigger this only, so it has just created like this. The point is that I have not tell my Python pandas library that what do I want, what kind of grouping do I want. I want the sum on the basis of the group. So if I type dot sum and trigger this function, now you see, on the basis of product, in case of endowment, the total premium I received is 4200. For fixed index annuity, for term, for variable annuity, the total number of policies I sold, and all these things. Okay, not only the sum, you can use a lot of functions. Let's say instead of sum I type mean over here, the average. So on an average, The total premium I received for one single policy is 1050, and on an average the number of policies that I have sold is 27, right? So not only this, there are a lot of other features available. For example, instead of sum type max, you will get the maximum premium that you have received in case of endowment is from the state zone D, that is 1200, and the maximum number of policies you sold was 42. So you see, that's how it works like. But now, is there a way through which I can get the entire data of this statistics that we have? The answer is yes, you can get that. So what you have to do is just type df dot group by. So on the basis of product I am doing dot describe, and if I trigger this, now you see over here, total premium is the one column, number of policies. So the count, how many for endowment I have sold, I have entries of 4 times. The mean 105, the standard deviation, the minimum value, the maximum value, the median value, the quartile 1, the quartile 3, same thing for the number of policies. I can even transpose it to make it look much more aesthetic. So you do this, type dot transpose, and now if I trigger this, that's how it looks like. If you see carefully, it is similar to the multi-index, right? This is one index, this is their second index. Super simple, and that's how you can get all of these values, right? So now let's say if I only want to see the values for fixed index annuity, so just copy this, paste it, and then just do the indexing, FIA, type this, and you get the values for fixed index annuities. That what was the average price premium, that is 650, the standard deviation for the premium, right? Median value for the premium, and all these things. So that is all about the group by. Now let's move on to the fifth topic, that is about the concatenation and merging. Okay, and in this concatenation and merging, we will first of all cover about the concatenation. We have covered it earlier as well. See, the concatenation simply means when you are combining two things together. So now in case of data frames, you can either combine columns together or you can combine rows together. So in case of columns together, we have to use the parameter axis is equal to 1. And in case of rows, by default, axis is equal to 0, or you can type it if you want to. So what am I saying? Let's take a look. Now, let's say I'm creating one more dictionary. I will create my data is equal to, the key is India, and their corresponding values will be, let's say 1, 2, 3, 4. 1, 2, 3, 4. Okay. Next key I am creating is, let's say Brazil. Their corresponding values will be, let's say 5, 6, 7, 8. Makes sense? Next I am creating is, let's say South Africa, and their corresponding values will be 10, 11, 12, 13. The last one I am creating is, let's say Australia, and their corresponding values will be 23, 24, 25, 26. Super simple, right? Now if I convert it into a data frame, so just simple df is equal to pd dot data frame. You can type anything. It is just that my hobby that I usually created using df underscore something. Just follow the Python program norms, nothing else. You can create even your own name parameter, right? So df is equal to pd dot data frame. So my data is my data, and so these are the column headings. Let's say now if I am doing create my rows heading, it will be, let's say, so these are 4 values, right? So I will call it, let's say a, b, c, d. So now if I check my data frame, that's how it looks like. Super simple. Now I will create one more data frame. Let's pick this, my data, put it over there, my data new, let's call it my data new, and the values I am putting is 10, 20, 30, 40, 80, 70, and something. Basically I'm trying to just change the values over here, nothing else. Okay, so this is my new dictionary, and if I then again convert it into a data frame, let's call it df1. Okay, so data is now my data new, and index. Okay, so now let's come to this index. Index will be also, let's say now index will be changed. Let's say if I create e, f, g, h. Now you see guys, how does my df1 looks like? So I have for e, f, g, h, I have the values for these four countries. Similarly, for index ABCD, I have values for this. Can I concatenate both of them together? The answer is yes. Obviously, we can see that we can concatenate both of them using rows, right? I want answer as to be like A, B, C, D, E, F, G, H for these four countries. How to do that? That is using concatenation. PD dot concat. Within that, you will type your data frames. So DF, that is your first one, and then DF1. And if you trigger this, that's how it looks like. I don't have to mention explicitly axis is equal to 0 because by default it is x is equal to 0. You can type that if you want, like x is equal to 0. Answer will be same, right? Similarly, if you want to stick together, basically on the right side, on the columns you want to stick together, then you will use axis is equal to 1. Let's take a look even in this example as well. So how does my DF looks like? That is my DF. Let's say if I want to add two more countries, let's say USA and China. Okay, let's call it more data dictionary I'm creating. For USA, I have uh, let's say 11, 12, 13, 14, comma. For China, I have 90, 92, 93, 99. Super simple. Now convert it into a data frame. Let's call it df3 is equal to pd dot data frame, and I'm putting it into my data is equal to more data, and the index that I will use will be similar, that is A, B, C, D. Make sense? So that's how my df3 looks like. Now I can concatenate both of them using the column side. So what I will do is I will just type pd.concat within that. So this is my df. I will type df, comma. This is my df3. So type df3. Now you see by default it has made it into a rows concatenation, whereas I want the column side concatenation. So I will type comma axis is equal to 1, and there you go. You see, that is the logic of concatenation, which simply means that you are gluing stick together data frames. In my example over here, I have shown you two data frames. You can combine as much data frames as you want. It's all up to you, right? Okay. You just have to ensure that the dimensions should match along the axis you are concatenating on. That is what I was saying, that about this EFGH that you are adding on the more index side. So basically it means you are sticking together on the rows side. Over here you just have to apply your common sense, nothing else, right? So we have covered about the concept of concatenation. Next topic is about merging. It is more or less similar to concatenation, but here the sometimes the column heading makes a big role. Consider it more or less like a VLOOKUP, basically the advanced lookup, I would say. In case of Excel, in case of SQL, it is more or less like a SQL joins. So how does that work? Let's take a look now. I will create a data frame df4, let's say pd dot data frame, and I'm passing on my data is equal to, let's say, the country, and within the country I have India, UK, USA, Singapore. Okay, this is my first key and their corresponding data value, sorry. Next key is, let's say, north, and their corresponding values will be, let's say, 100, 200, 200, 300, 400. One more key, let's call it south. Their corresponding values will be 10, 20, 30, 40. Okay. On a similar terms, I will create one more data frame. Let's call it df5. Okay. Instead of north and south, I will make it east and west. Super simple, nothing different. So now if I take a look at my df4, that's how it looks like. If I take a look at my df5, that's how it looks like. Now I want to concatenate both of them together, right? And I want to concatenate on the column side, which means I have to use axis is equal to 1. So if I try to do that, pd.concat, df4 comma df5 is comma x is equal to 1. If you see now, the country has come twice, right? Because technically concatenation is all about sticking two data frames together. But now I know about my common sense that this column remains same, country. And on that country basis, I can bring these two, east and west. So basically it is like a VLOOKUP, right? That okay, you will see the India. So for the east column, the answer will be 100. So on that basis, I want to apply my merging. That is where the concept of merging comes in. So how to do that? So again, let's take a first of all look at df4. That's how it looks like. df5, that's how it looks like. Super simple. Now let's see, what am I doing? See over here now. So I will type now pd dot merge. Okay, let's open this. Let's see what it is saying. You have to give your left data frame, you have to give your right data frame. So let's say on the left side my data frame is df4, which is this one. On the right side my data frame is df5 comma, what else they are saying, that on what basis you want to apply your the merging. I will use the inner. Now what is this inner? So if you guys are aware about the joins Venn diagram, so it is super simple for you to understand. Let's try to understand it over here. So let's say, this is my left table, which is df4. This is my right table. I am using the common column between both of these table, and on that basis I am joining these together. So my common column is country, and on that basis I am combining these two tables together. That is known as inner join, and that is what I am doing. How? Inner comma, then last parameter I have to give is on what basis you want to join. Because right now the Python is confused that okay, what was that column name on which you want to do that? So on is equal to country. Let's do this, and there you go, you get your answer. Make sense now? Country, north, south, east, west. That is the concept of merging is. I hope it is clear. Moving on, operations. So we will learn about three types of operations. In case of unique values, how to find the unique numbers, number of unique values, and unique values along with their how many times it has been repeated. Let's try to understand that with the help of example. Let's say I am creating a data frame where I am passing on my data as, let's say, first of all, let's create a dictionary, my data. So I will type dictionary where the product name, and I have values like term, endowment, pure endowment, and term. Okay, term has been repeated twice, that is fine. I will create one more key where I will pass on the premium amount. Let's say the premium will be 10,000, 20,000, 13,000, then 10,000 again, let's say. And one more key, let's call it geography, and passing it on as, let's say, it is the case of India, UK, USA, 1, 2, 3, 4, right? So let's say Brazil. Okay, now let's convert it into a data frame. So df is equal to pd dot data frame. My data is my data. That's how it looks like. Super simple. So now if I take a look at my data frame, that's how it looks like. That is something we know up to this point. One more feature, let's say, right now there are only 4 values, but in reality when you are working on the live data, you have like millions and millions of rows, thousands of, or maybe hundreds of columns. You cannot see the entire data at just one page. But is there any way through which I can get the summary of my entire data? Yes, you can just type df.info. So what is going on? Let's take a look. It is saying that these are the column names which we can see. Now it is saying that there are 4 values which are not null, which means that there are values that exist. There is not any single cell in which the value does not exist. And data type is object, which means a string over there. And you can see for premium it is an integer, for geography it is a string. That is something we can confirm. Makes sense? That is how you can get the values about the entire data frame, that whether there are any null values. For example, if it is 3 over there, it means that there is one value which is null. Okay, that is what it, that's how you can get the information about the entire data set. Coming back, now let's say I want to find the unique values in this product name column. What I will type, I will type df product name, then over there I will type dot unique. Simple sorted stuff. Term, endowment, and pure endowment, that there are 3 values, because we know that the term has been repeated twice, right? But the unique values are these 3. Make sense? So that's how you can get the unique values in a premium column. Now I want to find the number of unique values. Although right now I can see that, okay, there are 3, but in reality, when you are working with the millions of rows, you are not going to count each and every single thing. Make sense? So I will just type, copy this, paste this. Instead of unique, just type n unique, which means number of unique values. So we can see 1 2 3 1 2 3. Now let's say I want to find for each unique value how many times it has been repeated, similar to COUNTIF. Right now through my eyes I can see that, okay, that the term has been repeated twice, whereas endowment and pure endowment is just one time. But in reality, when you have a lot of data, how to do that? That is using the value counts. So I will type again my product name dot value underscore counts. And if I trigger this, you can see term 2 times, endowment 1, pure endowment 1. Consider it more or less like the COUNTIF function that you used to do in the Excel. Similar stuff. Make sense? Moving on, let's understand about how can you use the user defined functions that we have learned earlier in this case. Okay, so let's say, so what is my data frame? That is my data frame. And let's say this premium is the annual premium. Now I want to create one more column where I want to find the monthly premium. How to do that? So let's create one function. Let's call it def. I mean, we have to type def, right? And let's say the name of the function is per month. And I will pass on one value. Let's call it amount. And in return, what I want is amount to be divided by 12, because I am interested in the monthly premium and this is yearly premium if I am assuming right now. Trigger this. Now what you have to do is type the df premium. Okay, and you want to apply the function on this premium column. What was the name of your function? That is per month. You trigger this, you get your monthly values. You see 10,000 is the annual premium and 833 is the monthly premium. Okay, so you can use any kind of statistical, mathematical, more and more complex situation that you want, and you can just apply that on your data frame. That is what we are saying. And now let's say if I want to infuse this monthly premium column over here, we can simply do that. Just type, now I want to create one more column, right? So I will just type monthly premium is equal to df premium. Just basically copy this and paste it over here. Okay, and let's say, you know, like there are a lot of decimals. I will type, let's say dot round 2, so it will just give me values up to 2 decimal places. So now if I check my data frame, that's how it looks like. So we have added one more column using the user defined functions that we are creating, and that's how we get our values. Super simple. Okay, now let's say, what do we have? So we have covered this customize function. Let's talk about this built-in function, that is length function that you have available. So this is my data frame. Makes sense? Let's say if I add one more column, let's call it max age. 50, 60, 70, 75. And now my data frame looks like this. Okay, now there are some built-in functions such as len, which is about length, which we have covered in our strings lists as well. So same concept apply over here as well. So I will type like df of geography, right, which is this column. I want to apply. Now you can use the user defined functions which we have created, or you can use the built-in functions such as length. If I type len over there, and you can see that in this geography the length is 5 for India. 1 2 3 4 5, for UK 2, USA 3, Brazil 6. Okay, so we can use the built-in functions, which is this, or you can use the user defined functions that we have created. Next concept is how to sort the values and update the values. Okay, let's take a look. This is my data frame. So I want to sort the values on the basis of a premium. I will type df dot sort values. So first of all, let's close this. So first of all, on what column I want to do this? I want to do it on the premium. Okay, so now let's say if I open this, you see by default ascending is true. Ascending is true means that you will get the minimum value at the top and the maximum at the bottom. But if I type, let's say ascending is equal to false, so it will give me the descending answer, which means the maximum value, which is for the endowment, that is 20,000, that will be at the top, followed by pure endowment, then both term. So if I trigger this, you can take a look. Okay, so that's how you can sort your values. Next is about updating the values. Okay, so my data frame looks like this. Makes sense? Now you will say that why it has not been saved, because you have to use comma in place is equal to true, if you remember. So this is my data frame. Let's say I want to update the value for this pure endowment. The value right now is 13,000. I want to update it to 13,200. How can I do that? First of all, I have to locate this. I will type df dot ILOC, let's say index location. So 0 1 2, the row number is 2, column number is 0, right? No, 0 1, column number is 1. So if I check the value, you can see it is 13,000. I can just update it to 13,200. So now if I check my data frame, you can see the value has been updated. Super simple stuff that we have done over here. Okay, so next is how to find the index and column names, and how to find the null values or not a number values. Let's take a look quickly. So this is my data frame, right? And I will type df dot columns. Simple. So I will get the list of my column names, right? And if I type just df dot index, I will get the list of my range. Right now, like it is by default, which has been created. That is why you are seeing that it is over here, that it is like a range starting from 0, ending at 4, and step size is 1, right? If you remember, stopping at 4 means that the fourth number is excluded, so it will be 0 1 2 3. Same thing. So that's how you get it. Next is how to check the null values. You will just type df dot is null, and you can see false 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 everywhere. It means that there is not any null value in this entire data frame. Okay, so that's how you can check whether there are any null values or not. Last concept is about the pivot. This is just the theoretical stuff I have written. If you want to read, you can, otherwise you can skip it. It doesn't matter. I will teach you. Okay, now let's see. I will create a data. Data is in a form of dictionary. I have city. In city, I have New York, let's say. New York twice. Okay, and Chicago twice. Los Angeles, LA, and that's it, I think. So 1 2 3, so we have added 3 cities and 6 values. So this is city, and let's say year. For year, I have 2020, 2021, 2020, 2021, 2020, 2021. And last key is, let's say, sales that has been done. It will be 100, 200, 300, 150, 250, 350. Just the data I am creating, nothing else. So if I convert it into a data frame, if I check my df, that's how it looks like. Okay, super simple stuff right now. Now I am creating the pivot of my data frame. Pivot is simply about when you want to see it in a specific format by rearranging your index column and the values. Let's take a look. I am creating the pivot df. Let's call it anything, right? I'm creating a df new. So I will use pd, not pd, sorry, this is my data frame, right? So I will type df dot, I want to create the pivot. So I have to give the index columns and their values. Okay. So index means rows heading. Let's say on the rows side, I want the city name. So I will type city. Next is I have to give the columns. So on the column side, let's say I want to give the columns headings as the year. And the last is I have to give the values. Values will be for my sales. Now if I trigger this and if I take a look at my df, you see on the index side I have the city name, on the column side I have the year, and on the values I have the values for the sales. So you see, what am I concluding? That in 2020 in the city Chicago, the total number of sales was 300, which we can confirm it from here as well. 300. You are just rearranging it. Make sense? Super simple stuff. So this is pivot. There is one more, which is pivot table, in which you can also apply your aggregate functions as well. Suppose you want to combine the sum, you want to find the sum of the values, you want to find the mean of the values, and all these things. Let's take a look. So this is my data frame, right? Now I am saying df table, let's call it. So I am creating pd dot pivot table, and within that I have to first of all pass on my data frame, which is df comma. Next thing, you have to pass on the values. So let's say for me the values are sales, comma. Next is the index and then column. So for index I will pass on the city. For columns I want to pass on the year, right? Year, comma. I have to give the aggregate function that I want to use. I will type, let's say, numpy dot sum. If I, let's say, open this, you see by default the aggregate function is mean. It means you will get the mean average value by default. But if you explicitly mention that you want the sum, then you will get the sum. Trigger this, and now if you take a look at your df table, that's how it looks like. Okay, so that is the major difference between df and pivot and pivot table. I can give you one more example within that. Let's say this is my data. So with sales, I am just adding the profit as well. And let's convert it into a data frame. So that's how my data frame looks like. I have the sales and I have the profit. Make sense? So now pick this. So my values will be, let's say this time, sales and profit, both of them. So I can just put it into a list. Sales, comma, profit. Remove it from here. Okay. So now if I trigger this, and if I take a look at my df table, you see that in Chicago in year 2020, the total number of sale was 40, and so on, something. But if you don't mention this aggregate function, then by default it will pick the average value. Let's say if I remove this ag function, and if I now check my df table, you can see 20, because it is the mean value, average value. That is something we can confirm as well. I have written Chicago 2 times. So 20 into 2 is 40, which is the sum. You can see the sum. Make sense? So I hope that you all enjoyed this lecture. There is one more phase in this Pandas, third phase, where we will be finally touching upon the Excel and the CSV and how to deal with the huge amount of data. So with this, thank you so much, and I will see you in the next one.